going to start my lesson with a little review of inverse functions. Hopefully this is something you worked with both in Algebra 2 and pre-cal. If not a particularly difficult concept. But here's the idea behind inverse functions. You can think about a function really as a rule that takes an input and assigns an output. Okay, pretty straightforward. The inverse function basically undoes whatever the function does to the input to get the output. So essentially, instead of putting in an input and getting out the output, you put the output back in, it gives you your original input. In other words, it reverses all the processes. And this is an idea that we're very familiar with. A very easy example, if you go on Google Maps and you get a list of directions, say that you've got directions that say you're going to go north on 471, and then you're going to go west on 275, and then you're going to go south on 75. Maybe I'm driving to Lexington or something like that. You don't need to get back on Google Maps and find reverse directions as long as those roads travel both directions. You just go backwards through that list of directions in the opposite order. So you start out going north, do the last thing first in reverse. You go north on 75, then you go east on 275, and then you go south on 471. You reverse all of the directions and do the opposite. Okay, that is exactly what an inverse function does. Okay, from a mathematical standpoint, how does that work? Well, in a simple case, let's say I've got a function like y equals 2x plus 5. Okay, you put in an input for x. That value gets multiplied by 2, and then you add 5. Okay? If you want to reverse that process of multiplying by 2 and then adding 5, you do it in reverse order, and you do the opposite. So when you add 5, you want to do that by subtracting 5 from the inverse. And then you want to do the multiplying by 2 by dividing by 2. Now, that's probably not how you learned how to do inverses. The way you learned how to do inverses is probably algebraically. Another way about thinking about inverse functions is you have an input and an output, usually an x and a y. Really what you're doing is you're reversing the input and the output. So the other way you can do this, you can write the inverse function. The inverse function technically is just the equation written with the input and the output switched. So I can say x equals 2y plus 5, and that's an inverse function. Now, if I'm going to write things in function notation, you normally solve for the y variable. And notice when you solve for the y variable, it actually reverses all of the processes because you're working backwards through the steps that are being done in the variable. So I'll subtract 5 from both sides here. I get x minus 5 is equal to 2y, and then I'll divide both sides by 2, and I find out that y is equal to the quantity x minus 5 over 2. Well, check it out. I have x minus 5 over 2 equaling y. What does this function do? It subtracts 5 and it divides by 2. So you can think through the process, but you can also do it algebraically. It's very simple. Switch your two variables, and then usually you solve for your y variable just to put that into a function form. That's the basic idea, basically the Algebra 2 or pre-cal version of what you're going to do with an inverse function. Now, if you want to see what an inverse function actually does, for example, if I put in an input of 4, 2 times 4 is 8, plus 5 is 13. Okay, so an input of 4, f of 4, results in an output of 13. The inverse function basically undoes all of that. In the inverse function, if I input a 13, it'll undo all the processes. 13 minus 5 is 8, divided by 2 is 4. So in this case, f inverse of 13 gives me a value of 4. So you can see that the x and the y have been switched. The relationship for the graph of inverse functions is also relatively easy. If you look here, I have a very simple function, y equals x squared, and I want to show you what the inverse function, or how the inverse function relates to this function y equals x squared. So you can see I have different points here that would show up on the graph. The inverse function is just going to switch the input and the output. Again, that's the x and the y variable. So for the inverse function, to make a little table here, when I put in a 4, I'm going to get back a -2. When I put in a 1, I'm going to get back a -1. When I put in a 0, I'm going to get back a 0. Just switching the x's and the y's. 1 and 1, a couple of values here stay the same. When I put in a 4, I'm going to get a 2. And when I put in a 9, I'm going to get a 3. And notice when you plot that, there's definitely a visual relationship here that takes place. The point 4, -2 is on my graph. Okay, so 4, -2 is going to be a point right here. I have the point 1, -1, which is a point here. I have the point 0, 0. I have the point 1, 1, which is actually on the other graph. I have the point 4, 2, which is this point right here, and then I have 9, 3, which would go off my graph. But what you can see here is I'm really just getting a sideways parabola. And if you think about this, I'm switching the x and the y variables, so that should have result in a graph that looks really something like what I had before, because I'm really just switching the axes. So anyway, the key thing here is you get a new graph. Now, a couple of things here. First of all, and this is very important, notice that this is symmetrical along the line that cuts through there. So these things are symmetrical about the line y equals x. Okay, that perfect diagonal line. Very, very important fact. Second of all, if the first graph has the point x, y, you know that the other graph has the point yx. Okay, so switching your input and your output. And one other thing that's very important here, this is going to be crucial when we start working with inverse trig functions. Notice that this new graph is not necessarily going to be a function. Okay, in some cases your inverse, in linear equations your inverse will be a function. In a lot of other functions your inverse is not necessarily going to be a function. Now if I come over here, if I did want to find the inverse function algebraically, the inverse function would be switching the x and the y variables. That would be x equals y squared. You would take the square root of both sides, but remember, there are two square roots. There's a positive square root and there's a negative square root. So what happens is y actually ends up being the positive or negative square root of x. And so radical x looks like this. The negative square root of x is that graph down there, and that's why this thing doesn't work out to be a function. There are two possible output values for every input value, okay? But graphically, that's the relationship that you're going to see. Symmetric around the line y equals x, you're going to see each of your x and y coordinates switched. So even if you don't really know a lot about an inverse function, you can't look at the equation and graph it. If you know what the original equation looks like, it's not really all that hard to create a graph of the inverse.